Folks, we're going to talk about binomial probabilities today. We did go over the homework quiz from last time in class. Just come on in to see how you did on that and go over some problems. And we're going to talk about now some basketball. Okay, so through here, we're going to kind of work it out together because I did a lot of step-by-step instructions in class. So I'm going to give you just a minute to read through that. You can pause, and then I'll give you some more instructions after that. Okay, so we've got a conference tournament, and this is the championship game. There was a foul. I'm going to actually show you that real quick. Keep in mind, because I'm doing this over the video, you won't have sound. It's not super necessary. And because this video was from 2005, it is not the best quality. Okay, but here is that situation happening. Oops. Oh, look at this one. Sorry about that. Okay, so score is 75-73, but Memphis was fouled on their three-point shot. Okay, it's going to show you again a little bit better here. Okay. And now this person gets 3 chances to make up some points here, because when you're fouled on a three-point shot, you get 3 free throws that you get to shoot. And we're supposed to write out the sample space for this situation. Okay, remember, sample space is the list of all possible outcomes. Okay, what I want you to do is decide what the outcomes are possible when you're thinking about shooting a basketball. Okay, we have the option of we make it and we get the point, or we miss it and we don't get the point. So you get to pick the symbols that you want to use in your sample space. Just identify those. Pause the video and write that out for me, please. Okay, so I'm looking for, I went with making it just 1 since you get a point, and missing it 0 since you don't get any points. And we should have a total of first shot, second shot, third shot. Just like last time with counting principle, there are 2 options for the first one. You can make it or miss. And there are 2 options for the second shot, make or miss. And there are 3. So that's 2 times 2 times 2. There should be 8 ways this should happen. And what I'm going to recommend is that you stay organized when you're writing out sample spaces so that you don't miss any. So what I mean by that is take care of all the makes first. So that's make, make, make. Then maybe go to 2 makes instead of all 3. So make, make, miss. That miss could happen second instead, or that miss could have happened first. Now we're going to go to maybe 1 make. So that 1 make could happen first. It could happen in the middle, or it could happen last. Okay, and then no makes at all would mean all misses to finish our 8th different outcome. So our job is to decide, first of all, if Darius Washington is a 72% free throw shooter, what is the probability that Memphis, that team who was behind, will win, lose, or go to overtime? So the first thing I want you to do is decide which of these outcomes would go into each column and just write them there. So for this first example, the only way to win is getting, since they're down by 2, is to get all 3 points. And the only situation that happened was 1, 1, 1. Okay, and from kind of what we learned last time with independent events, we want this one to be a make, and this one to be a make, and this one to be a make. Because the shots are independent from each other, that just means this 72% is happening for each of these different shots. And a better way to write this is 0.72 to the 3rd power. Okay, so what I want you to do is pause the video and, 1, type that in your calculator, simplify that, but then go figure out all of the ones that would mean losing and all of the ones from here that would mean tying, so going into overtime, and then find those probabilities for me. Okay, when you're done, you can come back to the video. Okay, so here there were 4 ways to lose, so you could just make exactly 1. Okay, that's going to mean you lose because you only gained 1 point and you were down by 2, or you couldn't make any at all. And with this, the probability of making exactly 1 means the 0.72 counts once and the 0.28 counts twice. But there were 3 different ways that could happen, so I just did times 3. You may have written them separately, 0.72 times 0.28 times 0.28, and then maybe you wrote the 0.28 times the 0.72 and so on. But hopefully you realize that with multiplication, these numbers are commutative. It doesn't matter what order you write them in. So it will happen exactly the same values for all 3, so you can simplify it by just timesing it by those 3 outcomes for this one. You can't do it for all 4 though, because the last one is different. Miss, miss, miss means that 0.28 to the 3rd. Over time, there were only 3 outcomes. They all look the same. They all had exactly 2 makes. So that's the 0.72, we want 2 of them, and the 0.28, we just want 1 of them. And again, there are 3 outcomes, so we can multiply it by 3. What's really important when you're thinking about any sample space, remember, the probabilities must add up to 1 or 100%. So we could have easily written these as percentages since that's what this started as. So if you wrote this as 37%, that's great. You just tell me what you round to. But these 3 numbers together should equal either 100% or 1 if you're talking about decimals. Okay? So now what we're going to do is just take those values down to our next table, because that was the probability of Memphis winning, Memphis losing, or the probability of Memphis going to overtime. We don't know if they win or lose in overtime, but going to overtime. And now what we're going to do is talk about a running probability simulation. Okay, so when we talk about analytics for sports, they have some predicted, like at the beginning of the game, they're like, oh, we think that this team will win by this many. But as the game progresses, they update that probability or percentage based on the things that have already happened. And that's what we're going to do here. Okay, so I'm going to individually show you the 3 free throws, and we're going to update the probability of win, lose, or overtime based on what we see happen in the video. Okay, so again, the graphics aren't great and you won't have sound, but you'll get to see here's the first free throw. All right, so now you'll notice the score is 74-75. So we're going to update that. And now we're going to think about there are only 2 shots remaining, which means our sample space is not the same thing because that was 3 shots remaining. Okay, so what I want you to do is write out the new sample space based on there only being 2 shots remaining and find the probability of each. Make sure you show your work in each step just like on the last one. Okay, let's go ahead and check it. Our sample space for this one should have been make, make, miss, miss, make, miss, miss, make. Okay, so only 4 because we only have first shot, really it's our second total, but second shot in terms of remaining ones, make or miss, 4 total. Okay, so first one was the only way to win is making both of them from the last time, and that probability is pretty high since Darius is a good free throw shooter, relatively. And then probability of losing, relatively low, but overtime is pretty dang close to the winning as well. Okay, just like on last time, we can just multiply this by 2. If you wanted to add them separately, that would have been just fine. Let's go take a look at the second shot, see what happens. Okay, so he missed it. Score is still 74-75. From there, pause the video and find the probability with that last row for me. Okay, hopefully you realize that if he missed that, there's no way he could get all 3 points, which means there's no way they can get that 76, 75 final score that was originally possible. Okay, there's only one shot left, so the most you can get is 75. 75 is tie for overtime. If we think about the sample space, if there's only one shot, there are only 2 options. You make it or you miss it. So of those 2 options, missing it would mean you lose, and making it would put you at overtime. Okay, so let's find out what actually happened. And he misses it. So Louisville ended up winning that championship game. But what we want to talk about is, was it wise for Louisville to foul in the first place? I mean, we just saw the result. It ended up working out in their favor, but was it a smart choice? Okay, a lot of times when teams are losing, they'll foul intentionally because that's their only way of getting potentially gaining points back, is letting the other team shoot some free throws and hoping they miss. Then they get the ball back. But Louisville was the winning team at that point. Okay, so what I want you to think about is, if we know that Washington was a 40% three-point shooter, was it smart for them to foul? Okay, 72% from the line, but 40% on the original play that was fouled. Okay, so pause the video and think about that for me. Okay, hopefully you came up with something like no, or you're not sure. When we think about this, there was a 40% chance here that Memphis won, because that's the likelihood of or Washington actually making that shot with that. So this is if no foul happened. With the foul, the probability of winning looked like this 37% outright, and that's just to win outright, plus they could have potentially won in overtime. And here's the thing, we can't actually determine what that percentage is without more information. This 0.43 or 43.55% can't be put here directly, because of the overtime results, we don't know what the likelihood that Memphis or Louisville ends up winning after that case. So we don't know how much of it goes here, but this 37.32% is so close to this 40 that we would imagine, even if Memphis had like a 20% chance of winning overtime, which is not very high, it still puts them at an overall percentage of fouling being higher, which means Louisville probably wasn't wise to foul. Okay, usually the winning team doesn't do it intentionally. My guess is that foul was not on purpose, and they just ended up lucking out. Okay, so what we're going to do is take some notes on what we just talked about, and that process was actually a binomial probability. And here are the requirements for a binomial probability. Okay, we're assuming that we have bi means 2, so there are 2 specific options that are possible for the outcomes of a specific trial. So the trial in the last situation was shooting a basket. And there were exactly 2 ways to shoot a basket. You could make it or you could miss it. And a lot of times we can take any situation and split it into success or failure. So even if there's not distinctly 2 different ones when you're thinking about them, like heads and tails, you can split them up in a way so that they are binary. For example, if we're rolling a die, we know there are 6 outcomes, but we could split it into rolling a 1 or not rolling a 1. Anything that can be split into a complement situation, okay, can be considered binary. The next thing I'm going to talk about is independence, and that really goes with these two bullets. The idea of independence means one trial happening this way is not going to make the next trial more likely or less likely to happen that same way. Okay, it will not affect it. They are entirely separate. So flipping a coin, entirely independent. Anything that has replacement, so something's taken out but it puts it back in before the next option, independent by nature. Okay, but because they're independent, it means the probability is the same thing for every single trial. So that's really just the definition of independent. And then the last thing, we have to have whatever number of trials we're going to do known ahead of time. So we knew ahead of time we were shooting 3 free throws. Okay, we know if they miss the first 2, they're not going to actually shoot the third one if time is up because there's no way to win or tie. But in general, there was a fixed number at the beginning. Okay? And what we did for the calculations of the probability is generalized by the binomial theorem. Okay, so this is on your note card, and I want to talk about some of the pieces here. So this first piece we talked about last time, remember C is for combination, and this just tells the number of ways to choose some items from some other items where order doesn't matter. So I'm going to have you flip over your paper and go back to the front side for me, and we're going to add a little bit of notes there. So going to your original table here, I want you to just focus on this piece where we had one make, or we could have thought about it 2 misses, which means the same thing. So how this works is we're talking about the number of ways to do this. Well, we saw there were 3 ways to do it, but a lot of times we're going to be dealing with sample spaces that are much larger than just 8, so it won't be as simple just to list them out and count because there could be 100 different outcomes, and we have no idea how many times these items show up. Okay, so we're going to use instead our combination. So we had 3 trials that we were looking at, and we wanted to choose from those 3 trials exactly one made. And I'm going to give you a second to type that in your calculator. Okay, but 3 choose 1 is 3. And that's this 3 ways that we came up here. And then the second part of the formula says take the probability of getting whatever you want to happen. In our case, we wanted 1 to be made. So the probability of making it was 72%. And take it to the power of however many times you want to make it. Okay, so that was just once. The second part relates to the leftovers. Okay, so I'm going to remind you of what we did last class. We had Taylor Swift, we're looking at a playlist of 8 songs, and we wanted to have exactly 2 Taylor Swift songs. And we talked about how that meant we needed 2 Taylor Swift songs, but also the 6 not Taylor Swift had to happen. Okay, that implies both have to be true. So the same thing here. If we have 1 being made, that implies the other 2 have to be missed. So this is the leftovers. The probability of miss is 0.28, and we need 2 of those. And that takes care of that second half of the formula that you see on the back side. Okay, so probability of whatever you want it to happen, however many times you want it to happen. Okay, that's what this K is, number of successes that you want. And then the 1 minus P is just your leftovers or your complementary probability. And then N minus K is the leftover from the total. Okay, so what I want you to do is take that formula and the requirements for making a binomial situation exist and answer the questions on your check for understanding. Please complete both problems and then come back to the video to check your answers. Okay, I want you to, when you're talking about explaining whether it's binomial or not, talk about all of the pieces that were the requirements, and I told you 2 of them kind of go together. So binary, there were 2 outcomes possible. You could get it correct or incorrect, right or wrong. Okay, so you're going to explain that. And it doesn't have to look in the same formatting, but you have to talk about all 3 of these pieces. Okay, so the next thing is we have to talk about why they're independent. Well, independent means that the probability of the thing happening doesn't change between trials. So you have A through D on each question and you're guessing. That means the probability is going to be the same every single question. And then you had to have a set number, and that was 5 for us. Okay, so using our formula, the combination part, 5 is our total number of questions. And I'm going to add on here, a trial is a question in this case. Okay. P is equal to 1 out of 4, because with your guessing on a multiple choice question, A through D, there are 4 options, and only one of them is going to be right on the answer key. So that means the leftover probability is 0.75. And we wanted exactly 2 of them to be right, and we wanted the leftover 3 to be wrong. Okay. Next one here. Again, these 3 requirements, 2 outcomes, win or lose. Independent happened because we were replacing the ducks between games. Our trials in this case were each game being played. And replacing the ducks means you have the same 100, meaning you still have 20 over 100 being our probability of success, or 0.2. So then 10 total games we're playing, and we wanted 3 of them to be winners. So probability of winning to the power of that 3. And then leftovers, just 1 minus that, raised to the rest of the numbers that would get you to 10. That's it. Your homework is on Sapling, has a bunch of review. This is technically our last topic that we're going to talk about, but we'll practice more of it next time. Please come see me if you have any questions.